Alright, so we're going to solve a system of equations algebraically. We don't solve systems of inequalities algebraically because you can't properly tell what you're looking at that way. So first, in order to do that, this linear equation, or any equation, needs to be solved either for y or for x, and in this case neither of them are. So it'd be easiest to solve the linear. So let's solve the linear for y. If we solve for y, this will become y is equal to x plus 5. Okay? Which means we can take this and replace it, with y in our other equation. Alright, so this new equation we're going to get becomes 4x squared equals negative 17 x plus, always use parentheses when making a substitution, no matter what. It prevents errors. Now let's solve this to figure out what x is, and then we can find out what y is. Now just to make sure we know what the situation is, this is some line somewhere, and this is a parabola. So that's 4x squared equals negative 16x, that's this plus 9. Alright, that'll then become 4x squared plus 16x minus 9 equals 0. Now to factor this completely, doesn't have a GCF. This is a perfect square polynomial. This has a square root, this has a square root. That's 2x and negative 3. Multiply that by each other. That's not this. So, alright, so let's factor by grouping. AC is equal to, it's 4 times negative 9 is negative 36. Two factors of 36 that add up to be 16. So, we have negative 12 and 3. Negative 12 and 3, which won't work. So I need this number to be bigger and that number to be smaller. This one to be positive and that one to be negative. So what number goes in here? 5, 6, 9. I need something bigger than this. 18. So 18 and 2. Negative 2. So that'll become 4x squared minus 2x plus 18x minus 9. So these are our groupings. That's equal to 0. Can't just make things disappear. So that's 4x times x. No, not 4x, excuse me. 4 doesn't go into 2. 2 does. So that's 2x times x minus 1. This has a GCF of 9, so plus 9, leaving over a 2x plus minus 1, 2x minus 1. Equals 0. I'm going to scroll down for space. So that leaves us with x minus 1 times 2x. Oh, sorry. That should have been a 2 here. So that would be 2x minus 1 times 2x plus 9 equals 0. So either x is equal to 1/2, or x is equal to over 2, 9 over 2, negative 9 over 2. If I plug in 1/2 here, this part is 0. If I plug in negative 9/2 here, this part is 0. So those are the x values. Now that we know those, I'm going to write them over up top here. So either x is equal to 1/2 or 9/2. Was it negative 9/2? I gotta check that again. Negative 9/2. So, now to find y, we can substitute it in here, substitute our values of x here. So, y is equal to 1/2 plus 5. So y is equal to 7/2. So one solution is 1/2 7/2. And the other solution will be when y is equal to negative 9/2 plus 5. So y is equal to 5. That's 10/2, so that's 1/2. So the other solution is negative 9/2 1/2. So those are the two solutions to this system of equations. Because we have two values for x, we have to check for both values of y. So there's one, and there's the other. Let's take a look at one more example. Now, originally when I was shooting the video, I tried to do this one first, and I did it in a way which required something we didn't use before. So just in case, we're going to try it another way. Now, I might not have an answer to this question that we can do currently, because we haven't covered the quadratic formula yet. Last time I solved for x, so I'm going to solve for y here, because that's what caused the problem last time. So this is the same thing as y is equal to negative x plus 5. This is a linear equation, and this is actually a circle. So you can imagine that this is a possible solution. So there might be two solutions. So let's substitute. So we know that y is equal to this, so we can replace y with that. So our new equation is x plus 3 squared plus, in place of y, negative x plus 5 minus 3 squared is equal to 53. So simplifying this a bit, we get x plus 3 squared plus negative x minus plus 2 squared equals 53. Expanding this will give us x plus 3 times x plus 3, which becomes x squared plus 6x plus 9. Not going to go into that now. This will give us x squared minus 4x plus 4 equals 53. We'll get 2x squared plus 2x plus 13 is equal to 53. I'm going to scroll down for space. Subtract 53 from both sides. This is a quadratic equation, so it makes sense to set it equal to 0. So that's 2x squared plus 2x minus 40 is equal to 0. We can factor this. It has a GCF of 2. So that's 2 times x squared plus x minus 20 equals 0. Looking for two factors of negative 20 that add up to be positive 5, which would be x plus 5 and x minus 4 equals 0. So either x is equal to negative 5, which would make this part 0, or 4, which makes this part 0. So those are the possible x values. Using those, we have to find out what the y values are. So the first one, if x is 5, and the second one is if x is negative 4. I think. Let me go back and check real fast. Other way around. -5 and +4. Check that again just to be sure. -5, +4. Okay, so if x is 5, we'll substitute it in here. Y is equal to -5 plus 5. So that's 5 plus 5, which is 10. So y is equal to 10. So that's one solution. And in the other one, y is equal to -4 plus 5, which is equal to 1. So these are the two solutions to this system of equations. Because we found two x values, we had to find two y values that go with those. Alright? So if you wanted to draw this circle, this is a circle through the point -3, 3, centered at -3, 3. It has a radius of radical 53. I'm not sure exactly how big to draw that, so I'm just going to put it here. And one of these points of this line are at -5, 10, so that's this way. That's one point, that's -5, 10. And the other one is located at 4, 1. So 4, that's -5, so 4 is pretty far this way. 4, 1, which should be a little lower, would be around here. Okay. And that's it.